Okay, this one's about distance and displacement, speed and velocity. Okay, the objectives here are to describe the differences between distance and displacement, describe the differences between speed and velocity, be able to recall the typical speeds, be able to recall and use the equation to calculate speed and velocity. Here's a spec, basically about distance and displacement. Pause it if you wish to read it. And then about speed and the typical speeds I'll be going through, and how to calculate speed and velocity. And finally, the higher tier there will be doing about circular motion. Okay, so first of all, difference between distance and displacement and speed. So let's have a look at distance and displacement, and you may need to take notes of the two different things. Distance is how far an object moves. It's a scalar quantity, does not involve any direction. Displacement includes both the distance an object moves, measured in a straight line from the start point to the finish, and the direction in the straight line. Displacement is a vector quantity. And speed and velocity, you may need to take notes on this too. Speed does not involve direction. Speed is a scalar quantity. Velocity of an object is its speed in a given direction, so it's a vector quantity. Let's have a look back now. You need to be able to recall typical speeds, and you also need to be able to recall and use the equation to calculate speed and velocity. So things to write down, you must learn these, please. The speed at which a person can walk, run a cycle are things they want you to know. So typical speeds may be the walking is about 1.5 meters per second, probably a bit faster for you young guys. Running about 3 meters per second, that would be a typical slow jog. And cycling about 6 meters per second. You do need to learn these. It could ask you on the exam for these speeds. If it is not only moving objects that have varying speeds, the speed of sound, the speed of wind also vary. So a typical value for the speed of sound is 330 meters per second. So you need to write down here what's in red because you need to recall these facts. Okay, the speed equation, I'm sure you've done this before. Distance traveled is speed times time. Here are the units. Distance measure always measured in meters and convert to meters if it's not in meters. Speed meters per second and time in seconds. Rearranging the equation, speed is distance over time, and you use the symbols V for speed, V for velocity or speed is S over T. And also time would be distance divided by speed. You may want to write down what's in the red. Okay, here's a screenshot from a Fuse School video on speed, distance, time if you wish to watch it. And it shows you Usain Bolt's speed, which is on the next slide. Usain Bolt traveled 100 meters, ran 100 meters in 9.58 seconds to get the world record. So his average speed would be 100 divided by 9.58, which is 10.44 meters per second. This is an average because actually he was accelerating throughout the race. Here's another example. Calculate distance traveled by a cyclist traveling the speed of 6 meters per second for 2 minutes. Always convert the time into seconds. So do that first, and then you put it in the equation, and you get an answer of 720 meters. Example number 3. This time you're going to calculate the time taken for sound that reaches from a thunderstorm 2 kilometers away. And the speed of sound taken is 330 meters per second. So this time you must convert the kilometers into meters, so it's 2,000 meters. Then put in the correct version of the equation, and you get an answer of 6.1 seconds. So that's a thunder. That's how you'd hear the thunder, would be about 6 seconds after the lightning, because lightning travels much faster, almost instantaneously. As always, hope this video is useful to you.